3.3 rules for differentiation. Find dy dx. I'm going to write it as y prime because it's shorter.
That does not sound so.
Hold on one second. Miss Greer's calling me. She's at the store for me. I don't know where my phone is. Oh, it's right here.
Take your time. All the time.
Hello.
Hey, sorry, I know you're teaching.
No, you're good.
So they're out of helium. Do you want me to try another one?
Oh, yeah, if you don't mind.
Okay. Do all of them have or should have?
I know the one by Kroger usually does. You might ask, are you still in there?
No.
Oh, okay. I'll say you might ask them if they know who has it, or maybe call one of the other ones and say, hey, just wanted to check, do you have helium? If all else fails, I would say just go to Party City. They're just going to be more expensive.
Okay. Alright.
But I would think the one by Kroger would have it on Victory.
Okay. Alright, I'll check there.
Okay, thank you.
Alright, yeah.
Bye. Okay.
Just love helium.
See what happens. Alright, y equals x cubed over 3 minus x.
I love that box. Looks so friendly.
You gotta fight that box. Gonna be like, BAM!
No, not the box.
Take it out.
I'll take care of the box for you.
So if you need to, I mean, I don't normally rewrite it, but if you needed to, you could rewrite this as 1/3 x cubed minus x, just for the visualization of us taking a derivative. So we're using the shorthand method now. So we take the exponent, multiply it in front, and then subtract 1 from the exponent. So 3 times 1/3. So that would just be 1. And then x to the 2 minus, this is x to the first, so when I put the 1 in front, that's going to end up being a 0. So x squared minus 1 would be the derivative of that.
Oh, I like that one.
Wait, can you do how you got it one more time? Like just
Yeah, so you multiply the 3 in front of whatever, or like whatever the exponent is, you multiply it in front. 3 and 1/3 just happen to cancel, so that's gone. And then x, we take 1 away from this, so this would be a 2. And then over here, this had a 1 on it, so we put the 1 in front, so -1. X to the 1 minus 1 would be x to the 0, so it's just gone.
understand.
6, y equals 1 minus x plus x squared minus x cubed. Alright, so y prime, the derivative of a constant is always 0, so that term's just gone. The derivative of negative x would just be -1, because the exponent's going to go away. Plus, we put the 2 in front, and then take 1 away, so 2x. Put the 3 in front, so that's going to be -3x. Take 1 away to the 2, so -3x squared. Okay, these ones are finding the horizontal tangents of the curve. So basically we just take the derivative, set it equal to 0, and then solve for those values. So y equals 4x cubed minus 6x squared minus 1. So take the derivative, multiply the 3 in front, so that's going to be 12. X, take 1 away, so x squared, minus, multiply this 2 in front, so that's going to be 12. Take 1 away, so x, and then derivative of a constant is 0. So then I take this and set it equal to 0 because I'm looking for horizontal tangents, and then I'm going to factor. So I'm going to take out a 12x, and I'm left with x minus 1. So that would end up telling me that x equals 0 or x equals 1. And that would be where the horizontal tangents are. And some of them don't work out nicely, so I'm just going to warn you. Let's do another one of these. 12. Y equals x to the 4th minus 7x cubed plus 2x squared plus 15. See if y'all can tell me what you think the derivative is of this one.
4x cubed minus 21x squared plus 4x equals 0. Are we still doing that?
Yeah.
I was gonna say plus 0. But that's
Well, I thought you were about to say, I thought when you were saying equal 0, you meant like in place of the 15, and I was like, okay. And then I was like, oh no, you mean like go ahead and do the next step. All right, so first I would see if there's anything we can factor. So I would start out by taking out an x. So I have 4x squared minus 21x plus 4. So can this factor? Are there factors of 16 that give you 21? No. What might I need to do then?
the derivative again.
I think you can do that.
You can, but not for this.
Well,
You
I-
can take
I
as
meant-
many derivatives as you want.
I meant like for this,
Oh.
what we're trying to do here. So, well, I guess we could do the quadratic.
So I know that x is going to be equal to 0 as one of them, right?
Just leave enough space for it.
Because the x out here.
I was gonna say, where'd that other line go?
I just was like doing this and then it just drew a line. Then it wouldn't go away. All right, negative times negative, so 21 plus or minus the square root of 21 squared minus 4 times 4 times 4 over 2 times 4. Now, for the sake of saving time, this is going to be 21 plus or minus the square root of 377 over 8. So if you actually solve these down, because we're trying to get actual x values, you're going to get x is equal to, on the positive one, 5.05, on the negative one, 0.198. Okay. So now we're going to be using the product rule and the quotient rule that you had in your notes. So 16 x squared plus 1 times x cubed plus 1. So, because I'm sure you're going to ask, yes, I could FOIL this and then take the derivative, but I want you to use the product rule right now. So, the product rule says I do the first, so I copy the first number down exactly, so x squared plus 1 times, so if this is u and this is v, this is u, v prime, so the derivative of this one, which would be 3x squared. In product rule we add u prime, so the derivative of the first is 2x times v, which is x cubed plus 1. So I'll usually say first times the derivative of the second plus the derivative of the first times the second in terms of how I remember it. And then once you've done that, you just multiply this stuff out and simplify it, and that will be your answer. So this is going to be 3x to the fourth plus 3x squared plus 2x to the fourth plus 2x, and then just combine stuff. So 5x to the fourth plus 3x squared plus 2x.
And that's our derivative.
Yeah, that's your...
Makes sense to me.
I guess I could have written y equals up here. So product rule overall is not that hard, and in most cases, now I say that, like with where we're at right now, in most cases you could also multiply it, like FOIL it, and then just take the derivative the normal way, and that can also be how you verify your answer. When we get into stuff with like the derivatives of trig functions and stuff like that in 3.5, and we start doing product rule with that, then it gets a little different, where you can't really just multiply the stuff because you don't know what things are equal to necessarily. And you'd still end up having to end up doing a product rule after you multiply because it's still not going to break it down all the way. So let's see, the next one in here is a quotient rule. And this one's really important about the order. So x squared plus 5x minus 1 over x squared. So the quotient rule, so this would be u, this is v. So it's u prime v minus uv prime over v squared.
And for the product rule, that was just like, because I'm writing the formula, it's just u times v prime plus u prime plus v
Times v.
times v.
The quotient rule is a little harder to remember, but I remember in both cases. So like if you look at it, product rule and quotient rule, they both go in the same order, but in the product rule, the inner terms are what you take the derivative of. In the quotient rule, the outer terms of what you take the derivative of. And then really the only other difference is the sign in between them.
So for the product rule, does it matter which one's u and which one's v?
No, I just usually do them in order,
Okay.
but it doesn't matter. It does, I mean, the way that I would say the quotient rule is the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Because it does matter what's u and v in.
Can we say that, but at like quarter speed?
How about I write it?
It's a good idea.
Derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. See, if you actually listened to your notes, you would have heard that.
Maybe. That's one secret I'll never tell.
I think she's trying not to self-incriminate herself.
Maybe just a little bit.
Just a tad.
I know the real truth.
What happened to your arm, Virginia?
From volleyball.
Oh.
It's like a speckle
I
bruise.
I thought you like used the whatever you're using to write with them,
like
and like
drawing
kinda,
on
like,
myself?
She was just like,
I was just like this the whole time.
she's been like this.
Just when I get bored, you know.
Yeah, I probably have a bruise on my head. They hit me in the head.
Yes, like she was taking a picture and this ball came out of nowhere.
It was like,
And
BAM!
Bam!
I was like,
She's like, put the ball away. I still don't even know who threw it.
well,
Oh, that's what I thought.
Show later.
yeah. All right, derivative of the top. What's the derivative of the top?
Okay, so there's like x.
2x.
2x.
And
2x
that's the 2.
plus 5.
Yep. Times the bottom, x squared. Minus the top, copied exactly, x squared plus 5x minus 1. Times the derivative of the bottom.
You got this, Virginia.
No, I didn't. I messed up. Okay.
Girl,
X.
this is why I use pencil.
It's
Because I
not
can
pretty.
trace it.
The derivative of the bottom? 2x.
It's not pretty when you have to scribble things out.
All over bottom squared, so x squared squared. I'm just doing that for reference so you can see it. I a lot of times will just go ahead and square whatever it is. Alright, so on top I've got 2x cubed plus 5x squared. I'm going to try to do all this at one time. Minus
Oh.
2x cubed minus 10x squared plus 2x all over x to the 4th. And then I would have negative 5x squared plus 2x over x to the 4th. I can like cancel. I would obviously need to factor out an x and cancel, but I think y'all are familiar enough with that at this point that I don't need to show that step. But this would end up giving me negative 5x plus 2 over x cubed. You can either leave your answer here, or the book will go on and write this like negative 5x over x cubed plus 2 over x cubed, and then reduce this to become negative 5 over x squared plus 2 over x cubed.
That takes up like a lot more space.
Yeah, so I don't care which way you put your answer is what I'm saying, but if you're checking your answers, just know if it looks different, that might be why. So check and see when you're doing it. Like if your answer is not showing to be right, check and see if that's what's causing the problem.
You know what we're doing in government today? Do I really wonder what we're doing in government today? Do I really want to?
You're writing 3 essays.
That actually sounds very realistic for that class. Unfortunately.
I hope we do notes because then I just lay on the floor.
Yeah, but we got to the last section.
Oh. Then we're not doing notes.
All right, so with this one, we're still in a quotient rule, but I also have products. Now, eventually, we will have things that, like I said earlier, we can't just straight up multiply. But I really don't want to deal with two product rules within a quotient rule. At this stage in the game, y'all are not far enough in to be ready for that yet. So, and it also just makes it harder if you do it that way. I would recommend you just straight up FOIL top and bottom, and then we'll take the derivative of that. So what do I get when I FOIL the top?
X squared plus 3x plus 2.
How about the bottom?
X squared minus 3x plus 2.
Yep. So almost the same, but just a little different. So now, keeps running away. In the last class, it switched to Friday Night Lights. Like, I'm like literally mid thing, and all of a sudden Friday Night Lights pops up on my screen, and I was like,
Guys, I can explain.
I was
I
like,
just started watching. Like, you know what? Why not?
well, no, it wasn't playing. It was just like on that page of like Netflix. I was like,
How long do the videos take to get posted?
it depends. But Lily was out, so I'll have to post that one.
Oh, so we can get a little peeky peek at that.
It was literally just the screen.
I literally have
Yeah,
two
but it's
episodes
so
left.
funny.
I've been saving them. I don't know when to watch them. I guess this weekend.
Yeah, a lot happens in the last two episodes.
Really? Okay,
Yeah.
I'm excited. I'm on like the end of 11, and I think it's 13 is the last one.
Yeah. It's kind of sad. I kind of wish they would have made more seasons,
I
but
know. Now I'm gonna find something else to watch. I don't even know. That's the worst part. Like when I finish a show, because then I like get attached to the show. And it's like,
I really like the show High Potential, but that comes out like a episode a week, so.
I hate shows when they do that. That's why I like watching old shows.
Yeah. I'll probably start back on Full House when I'm done with it this time.
Yeah.
I don't know. It's my rotation. Full House, Floor House, Friday Night Lights.
It works. I do not mind rewatching the same stuff. I would gladly do it, especially if I'm just putting it on in the background.
Yeah, that's true. All right. So now I need the derivative of the top
2x plus 3.
times the bottom. X squared minus 3x plus 2. I knew my line wasn't long enough. Oh no.
Oh. The horrors. There we go.
Now it's excessively long, but that's okay. Minus the top times the derivative of the bottom.
2x minus. Yeah, that's right.
All over
Something squared.
X squared minus 3x plus 2, and then we close the parentheses.
B squared. Yeah.
Now, I would not recommend from the start multiplying or like multiplying the denominator. I would leave it as whatever squared because oftentimes it works out that stuff cancels, so it's really nice, or it's just not even worth like expanding because it's not going to make anything cancel. So, on top I've got, oh boy,
This is gonna be a lot.
2x cubed minus 6x squared plus 4x plus 3x squared. I'm not going to have enough room. Minus 9x plus 6. Oh boy. Minus, I'm going to bracket this off. I'm not going to try to do everything at once.
That's a lot.
2x cubed plus 6x plus 4x. Nope, 6x squared.
Don't know how to say it. No! Slow.
Minus 3x squared minus 9x minus 6. I did it!
She did it.
All over. Sometimes I'll just do this too if I'm like in between steps. I'll just do like a placeholder for it because Why not? So then at this point I start looking at if stuff's going to cancel, because a lot of times it does. So 2x cubed and this minus 2x cubed is going to happen because this negative's going through to everything. 4x and minus 4x will cancel. Those have the same sign. Negative 9x and then the minus the negative, so plus will cancel, so the 9x's are canceling.
It's like, you're canceled.
It's 2024.
Yeah.
Alright, so then I've got, when I put this negative through, everything here, I've got negative 12x squared. I know I'm going to have other stuff too, but plus 6x, right? Squared. 3x squared plus 3x squared. So plus 6x squared. And then 9 minus a negative, so, I can't talk. 6 minus a negative 6 is plus 12. All over that stuff squared. So then I end up with negative 6x squared plus 12 divided by x squared minus 3x plus 2 squared. And that, honestly, you can just leave it there because it's not going to be able to break down any further than that. And what you'll notice is a lot of times the book will just leave it like this too. Obviously, like in the first one we did, we broke it down just because of, it was something easy. Like, it was just x to the fourth. So we split it up. But when it's something like this with multiple terms, a lot of times they just leave it as whatever it is squared.
Will they take that on the AP exam?
A lot of times it will look like that. Some of the questions about derivatives will literally just be the setup of it. So, like, your answer option will just be set up the thing.
You know that it just stops there, just like because nothing will factor from the bottom. Like is there a way to know before I try to do that? Like if I'm
Well, considering I know what this was to start with, and I know that I'm not getting that from what I have here, I kind of just know. But I also look in the book, just leaves it like this. I just kind of know how the book leaves it at this point. So, I mean, if it's something that you know can factor, then yeah, obviously you should. But that's just going to be an excessively large thing on the bottom, which is not wrong if you multiply it through. It's just you don't need to. Yeah. All right, we're going to do one more and then we'll stop there for today because that'll kind of be like a good stopping point. Not quite halfway, but close enough because the next stuff is a little different. I mean, it's still this like finding derivatives, but so 24, the instructions say, suppose u and v are functions of x that are differentiable at x equals 2, and that u of 2 equals 3, u prime of 2 equals negative 4, v of 2 equals 1, and v prime of 2 equals 2. Find the values of the following derivatives at x equals 2. So A is d dx of u v. So essentially, we will expand this out in terms of letters and then replace it with the numbers. So product rule would say that this is what?
U times v prime plus u prime times v.
Yep. So then this is going to be, we plug in the number, so 3 times 2 plus -4 times 1, which is just 6 minus 4, so 2.
The ddx thing is just like y prime, right?
Yeah. It's just a different way to write it. It's just saying take the derivative of the function with respect to x, because it doesn't actually explicitly give you the function, so that's the main reason they wrote it that way. B d dx of u over v so I need my quotient rule for this one.
U prime times v minus u times v prime over v squared.
Yep, and then just plug in. So -4 times 1 minus 3 times 2 over 1 squared. So that ends up just being -4 minus 6, so -10. C d dx of v over u. Gonna mix it up on you and see if you know what you're doing.
Sure.
Do you just like flip the equation?
I mean,
Or do you-
the equation stays the same. It's just because it's always.
Hold on,
That's
let me
why.
take this.
That's why I gave you this,
Oh.
Okay, so we
because I know that they'll mix the letters up on you. So essentially, just flip these letters.
Oh.
v prime u minus u prime v over.
No, minus v u prime.
That's the same thing.
That's not what you said.
It's the same thing,
What did you
Virginia.
say?
Do you remember the rules of?
But you're gonna get
multiplication?
it confused because I said that derivatives of the quotient rule are always on the outside. You're gonna end up getting confused if you do it like that.
Yeah.
Just think of it as, I don't know, I don't remember what it was, but one of those like,
Commutative.
one of those whatever the things are.
Oh, the
And then
double angle thing or the 7 difference formulas?
Yeah.
Okay, anyways, what is the
Square root
denominator?
squared. I'm glad that you understood what I meant.
U squared.
That's what I said.
I did understand.
Alright, v prime is 2 times u is 3 minus v is 1 times u prime is -4 all over 3 squared. So that's 6 plus 4, so that's 10 over 9. d dx of 3u minus 2v plus 2uv. Now, the nice thing about this one is I already found the derivative of u times v, right? So all I have to do essentially is take and plug that in. Now, I will write it out like this first, but then I'll just take and replace it with that number because I've already solved for that. So what would the derivative of this be?
Like just plugging in 2, 4, wait.
No, don't plug in anything. Just take the derivative of this. So what's the derivative of 3u?
3.
Nothing.
Use a function.
U
because it's a function, so it'd just be like y prime, u prime, minus,
2b prime.
yep, plus 2 times, I'm going to make you do the product rule again.
U times v prime plus u prime times v.
Yep. So now when I plug in numbers, I already know that this is equal to 2 from the previous part, so I'm just going to replace this with a 2. So this is 2 times 2. 3 times u prime was negative 4, minus 2 times b prime was 2. So negative 12 minus 4 plus 4, so negative 12.
Like I understand how to do it, but it takes me a second to get it all.
To register.
Yeah.
All right, so that's it. That's where I'm going to stop for today, because the next stuff kind of gets into like another topic within this stuff. I still have like 3 pages of examples, but the one should go kind of, a little bit of it should go kind of fast. Might finish it on Monday. We'll see. Do y'all want problems or no?